Hello, everyone. Good evening. Today, I'm going to talk about introduction to blockchain. My name is Ramesh Ramadas. I serve as a co-chair of the IEEE Blockchain Initiative. I also serve as the blockchain coordinator for the IEEE Puerto Rico and Caribbean section. So here's the outline of my talk. So I'll first talk about the blockchain evolution as a whole field last 12 years. And then we will spend some time on the digital cash, the concept of electronic cash. And then we will talk about Bitcoin, spend a few minutes on that. And then the next section is on Ethereum. And once we cover those two things, we will try to understand what's happening in the cryptocurrency space and startup activities, and then the use of blockchain in enterprise uh, use cases, and finally, government use cases. So let's start with the first section on blockchain evolution. So this slide shows the three stages of evolution of blockchain field, starting with blockchain 1.0 being, the launch of Bitcoin and altcoins inspired by Bitcoin. Primarily, all of them are, collectively called as referred to as cryptocurrencies. As you can see on the right side, that there are some dates there. Bitcoin was launched back in January 2009, and now looking at the second phase of the evolution was blockchain 2.0, the green circle, which is primarily the start of programmable chains where you can actually program smart contracts. We'll talk about that later on. So around 2015, um, Ethereum, and then Corda, Hyperledger, several blockchains were launched, and as I said earlier, you can program on these blockchains. And now let's move on to the third circle, the big one, the blue circle, which we have it as blockchain 3.0, DLT, which stands for distributed ledger technology, and DAG, it stands for directed acyclic graph. And so those architectures were launched to address various limitations of some of the blockchains in 2.0, like the scalability and interoperability issues. So this slide shows some of the definitions of common terms we would use today. Uh, Distributed computer network is one terminology that you would hear quite a bit, which is basically a collection of autonomous computers that appears to the users as a single coherent computer. As a matter of fact, the cloud services that we use today are of that type, distributed computer network. Now, DLT stands for distributed ledger technology. It's basically append-only transactions, and blockchain is basically a chain of blocks. Each block contains transactions. We will talk more about this in a few minutes. DAG, finally, you have the definition for DAG. It's also a type of mathematical um, structure where it's being used to realize DLT architectures, such as IOTA and Hashgraph, which we had on the previous slide. Now let's talk about digital cash and then Bitcoin. So digital cash, money or currency, refers to any means of payment that exists purely in electronic form. There's no physical, tangible, dollar bill or coin. It's completely on a computer system or systems. And since the late 1980s, there have been several attempts to create digital cash, and you can see the list here, like 1989 DigiCash, 1996 eGold, 97 Hashcash, 98 B-Money, and 2005 BitGold. B-Money and BitGold were theoretical concepts. And then 2008, Bitcoin was launched. As well, the white paper was uh, published, and then the actual code was launched in January 2009. So let's look at that, more details here. So Bitcoin is the first successful digital cash deployed on a computer network, specifically a peer-to-peer computer network. And the dates are there. We already talked about these dates. October 2008, uh, anonymous person goes by Satoshi Nakamoto published the white paper, and then uh, January 2009, the code was launched. Now, Bitcoin didn't come out of nowhere. It's actually a recipe based on several key ideas, uh, and which we've been around for many years. Like you can see a list of ideas. 1976, public key cryptography. Then 1979 Merkle trees, and 1990s timestamping. And there's also proof of work algorithm 1997. And there's also 2001 secure hash algorithm. So Bitcoin basically combined all of these ideas, and that's how it was implemented. Now, if you look at the architecture, Bitcoin is basically a software that runs on a peer-to-peer computer network. Uh, just to give you an example, Skype in the early days, Skype was a peer-to-peer software that was used to make calls, and so Bitcoin is something similar, where it's a software running on a peer-to-peer computer network, and it consists of some of those components you see here. Ledger, like you see on the right side, we have this layers like that shows conceptually different components. Like there's a ledger. The ledger is where all the data is stored, and in this case, every computer, which is referred to as a node, stores the ledger. And there's a protocol that determines how the data or transactions are added to the ledger. And then there's the wallet. Wallet is an application, how a user actually interacts with it. Now, the next few slides, I'll go through each one of these uh, concepts, and then we'll have we'll dive into Ethereum. So let's start with account and key. So just to step back, so Bitcoin is basically was created as an electronic cash. So a user who wants to send money to another user both parties must have an account on Bitcoin, so that a user A can send Bitcoin to user B. So the account, that's what this account is. An account, it basically consists of a private key and a public key. So there's an example here. It's a long, string of hexadecimal characters. So this is how it looks: private key and public key. And just like we have login and password, like login email, it could be an email or your some ID that you create, and there's a password. Similar concept here, where password, we don't give out to anyone, just a login email or something we give out. So same thing, public key we can share with anyone for receiving Bitcoin. The private key you keep it, to yourself, just like you would keep your password for any websites or bank account, for that matter. And so wallet is basically it's an application which is used to generate, manage, and store private and public keys. So think of it's like an application. I think most of us know, like Apple Wallet, so where you can add multiple cards, credit cards. So similar idea here. You can have multiple Bitcoin accounts on a single wallet. Some of the examples are like there's a MetaMask, which is a non-custodial wallet. And there's also, you can also create a custodial wallet, meaning you can sign up to an exchange. Some of the exchanges, like Coinbase is an exchange in the US, and you can actually log in and create an account with them using your email address and, create a password. So there are two ways to, create account on a blockchain, Bitcoin or any other blockchain. One is, directly using a non-custodial wallet. So you store the private keys, or you could actually use another centralized exchange, and they store the private keys, the one we talked about, and it's a lot easier, I guess, for a lot of us. It's easier, to just use an email and a password to log into a site, and then they take care of, manage your private keys. But there's a risk of, exchanges getting hacked. So we won't have time to get into it. But let me move on to the next topic, which is actually a ledger. So we talked about ledger, like, Bitcoin is basically a distributed ledger on a peer-to-peer computer network. So what is a ledger? So before we talk about ledger, uh, let's talk about block. What is a block? A block is a data structure comprising of, there's a header and there's a batch of transactions. So let's say, you know, we talked about, a user A sending Bitcoin to user B, but there could be also a user C sending, Bitcoin to user D, and could be many transactions. So all of them could be added or, grouped, and that's how, a block is created. And each block is actually linked to the previous block through hashing. So that's why it's called blockchain. It's basically a chain of blocks, and they're cryptographically secured and connected, linked. And if you really want to know how this, works, there's actually a demo at the link. You can actually see how this, the hashing and the linking works. Now, Bitcoin was, you know, designed the maximum of 21 million in supply. And how are new Bitcoins created? Basically through mining. So mining is a process by which new Bitcoin is added to the circulating supply. And the folks who do the mining are called miners, and we'll talk about that on the next slide. So the protocol, if you recall, there was a layer by layer diagram that showed like there was a ledger at the bottom, and there's like the protocol, right? And that's this protocol. So the protocol basically is the governing algorithm, or in this case, it's proof of work algorithm, is used to actually add transactions to the blockchain, the ledger and the blockchain, or in this case, it's Bitcoin. So a new block is added to the ledger on the Bitcoin blockchain every 10 minutes. And the miners we talked about on the previous slide, they propose new blocks and they compete to earn this new Bitcoin. And this competition is basically, it involves solving a mathematical puzzle using the proof of work algorithm. And you can see at the bottom, this diagram shows like three miners. They're all trying to add the winning block. So you can see here, miner one, adds the winning block two, and then miner two, basically was the first one to solve this mathematical puzzle in the scenarios, and their, winning block three gets added, and then the miner three adds the winning block three. So you can see uh, the longest chain, which is actually, if you follow the path of the green blocks, that becomes the valid chain. And then the miners would start adding blocks to the longest chain. So you can see this. We're only showing three miners. I think if you check on the Bitcoin node network, there's over 12,000 nodes or miners that are running these. But uh, there are also mining pools, which we won't have time to get into it. But so just to mention that, you can search about mining pools. So now let's talk about Ethereum. Um, so on the right side, you see the layer comparison. So the difference between Bitcoin and Ethereum is Ethereum, there is a virtual machine, uh, which enables you to deploy a computer program, instructions or code, and you can change the state of the, you know, blockchain. So now let's let's look at smart contract. So smart contract is a computer program that's deployed on the virtual machine, and in the any change in, for example, you could write a smart contract where when certain conditions happen, the in this case the Ethereum gets transferred from user A to user B. So the conditions like if then, those kind of conditions can be programmed and could be deployed on this Ethereum blockchain. And the smart contracts can be programmed in Solidity, Java, or Python. So we will look at examples of what this enables. Right now, we're just going through some of these concepts. Later on, we will look at real use cases based on the smart contracts. So now let's talk about native asset. So native asset is basically, in this case, the cryptocurrency that's programmed at the protocol level. So in the case of Bitcoin, it's the native asset is Bitcoin, and in the case of Ethereum, the native asset is Ether. And to run transactions or execute transactions on these blockchains, in the case of you know Bitcoin, you would pay the transaction fees in terms of Bitcoin, and in the case of Ethereum, you would have to pay Ether, and it's called gas fees. Okay, now let's talk about tokens. So a token is a programmed asset, meaning a smart contract that's actually could be used to create a new type of digital asset called tokens. So there are two types of tokens that you would come across in the blockchain field. Uh, Very common ones like fungible, meaning interchangeable. Like fungible, for example, if I have a dollar and I could exchange that with anyone with that's a dollar, US dollar. That's interchangeable. That's And then non-fungible, meaning they're unique and not interchangeable. Like if I have a piece of art and someone else has another piece of art, we can't just change it. They're unique and they're not interchangeable. So in the case of Ethereum blockchain, there's a ERC 721 token standard. You can use it to create like a digital asset like art. You can so I think we have some data on that. We'll see that later on. Now, another concept, decentralized applications or dApps. So dApps are built on top of the virtual machine, and they typically involve one or more smart contracts on the front end, such as JavaScript, HTML, CSS. So in fact, the if you look at the website running dApps, it will look pretty similar to what we use today. The only difference is the back end. It'll be using all these blockchain stack, such as could be Ethereum or could be any other blockchain for that matter. Now we went through a few concepts and terminologies. The reason is you will see that's going to make you understand uh, what we're going to go through in the next few slides. Okay, now let's talk about cryptocurrencies and what startups are doing using these, blockchain, that, for example, Ethereum. So this slide actually shows the evolution of cryptocurrency, digital asset, and various emerging use cases of blockchain. So everything started with the launch of Bitcoin back in 2009, and Bitcoin inspired the launch of several altcoins. Actually, some of the coins were launched just literally taking the Bitcoin code and making some changes to it. Everything is open source, there's no IP. You can go find it on GitHub. And so now, around 2015, programmable chains were launched, Ethereum and other chains, and that actually set the stage for, a lot of the innovation that you see here. Remember, we talked about how you could, deploy smart contracts on Ethereum blockchain. So that programmability enabled like DAO, like decentralized autonomous organization, just purely running on smart contracts. The rules are coded by smart contracts, and then we talked about non-fungible tokens. There's decentralized finance. There's ICO, IEEO, and IDO, and there's a whole list of things that happen. And there's games, and lately there's a lot of talk about metaverse, how blockchain enables metaverse. So if you go to coinmarketcap.com, you would see there's over 17,764 cryptocurrencies. And this just shows you a snapshot of a few hundred. And as of today, the total value of all of these, they call it the market cap, is about 1.7 trillion. You can see it's a very volatile market. Now, if you want to understand what these 17,000 cryptocurrencies are, you can get some idea of what these things are. Like, one category is we have several infrastructure projects such as Ethereum. Like Ethereum is an example that we spent quite a bit understanding some of the key concepts such as smart contracts. We talked about tokens. We talked about Dapps, right? So similar to Ethereum, there are many blockchains. These are called infrastructure. Like they're like the foundational layer. So think of these as the kind of like the not the best comparison, but to make it easier to comprehend, they're similar to like operating systems like iPhone, iOS, or Android operating system. We have, and then on top of iOS, we have all these apps, right? We have so many apps on the phone, and similarly on Android phone, you have so many apps. So think of these are like the operating system level. And then on top of these, you could build a lot of applications. And here's a list of some of the examples, like we already talked about it on the evolution slide, where we have, decentralized finance, there's non-fungible tokens, which can be used to represent art or music. There's games, and there's metaverses. They're all built on top of, these blockchain infrastructure. Now, if you look at some numbers for these market segments, so you can see DeFi, there's 525 projects. You can see there's over $120 billion in market cap. And there's NFTs, there's games, there's metaverse. So you get an idea, like, there's hundreds of projects, and they're working on different use cases, emerging use cases. Okay, now let's spend some time on the enterprise use cases. Okay, this slide shows some, large companies. This is like based on Forbes 50, 50 meaning like blockchain 50, meaning like top large companies working on blockchain. So if you look at these boxes, right, these boxes are based on their use cases. Like you can see capital markets, and then you have supply chain logistics. Is for like tracking, like parts through the supply chain to make sure they're legit. And also there's payments, there's identity, there's trade finance, and so many use cases that are being explored, like even agriculture, like to track food, from the farm to the store. I think Walmart was, doing some pilot on that. Now, if you look at what kind of technologies they're using, if you were to look at, you see this graph, this slide shows at the bottom, you can see that blockchain used. So it turns out that the commonly used blockchain or DLT architectures are Hyperledger Fabric, Quorum, Corda, or Ethereum with some privacy implementations. Okay, so now let's move on to the last section, which is on government use cases. So here you see a few examples where blockchain could be used for government applications or services, like including digital currencies. I have a slide on that, and then we have budgeting, and also for public procurement, taxation, like for collecting taxes, and also for funding projects. You could put everything on blockchain so you can track where the money comes, who gets it, and how they spend it. You can completely see everything. Um, well, it's again, it's depends on what kind of blockchain they use, but even if it's a private blockchain, I think the citizens should get access to whatever they're using, because they are typically using tax money, right? Tax money is a public money, so we should be able to see where the money goes. So you can see a lot of use cases that could be done, and some countries are already using it. And I'll talk about those examples on the next few slides. So here is a very interesting use case where governments are looking at issuing digital currencies on a blockchain. So these are called central bank digital currency. So you don't need to print paper money and distribute anymore, right? If this is all done. But this graph, actually, this picture shows like some of the countries are at what stages they are. Like you can see, China is leading, as a matter of fact. I think they are live with their central bank digital currency. It's called digital yuan, and several countries are experimenting, like I think U.S. and you know several countries you can see are doing pilot right now on a small scale. And of course, there's actually pros and cons. Once a country issues their currency on a blockchain, and you can easily track. They can actually see who's getting how much, and of course, it's going to be a lot easier for the governments to tax citizens as well. It's all electronic, so they can even basically take out the tax money before you get it. So it's efficient, in the sense that distribution is efficient. You can transfer very quickly. You don't need to carry any paper or coins, whatever. But the drawback is, yeah, it can be tracked and traced and where it goes, and in some cases, I guess you could lose access to your account too. So that's interesting. There's also there's both sides to it. Just wanted to point that out. Now let's move on to the next use case where European Commission is building or funding a project called the European Blockchain Services Infrastructure, or EPSI, EBSI. So the goal of this project is to build a blockchain infrastructure that'll serve as a common platform for all the European Union member states, and they can do cross-border public services. Meaning, you know, let's talk about the first use case, like issuing an identity. So today, like if you're in Poland, they will give you an identity, and you go from Poland to Germany. You know, Germany would issue another identity. It's kind of similar to what happens in the U.S., where every state issues a driver's license, right? When you move to another state, you have to get a new driver's license. So it's kind of similar in the European Union right now, where every country has their own identity system. And what the European Commission is trying to do with this project is, there'll be one identity for the entire EU, right? So you could just go move across within the member states and just prove that you are who you are with one identity. If it's on blockchain, it can be quickly verified, and that's one use case. The other use case that they're looking at is data sharing, and also diplomas management, like similar to the identity issue. If you get a degree from a university in, again, let's say Poland, and the student moves to another country, France, and then they have to wait for some time to get all the transcripts and all that, the diploma. So here they want to put all the diplomas on this blockchain, EPSI, and also notarization of documents and data sharing and all that. So that's another use case, and there's one other use case which is not here. Is I could talk about it. Is in India, they're using Hyperledger Fabric to actually control the spam call, eliminate spam calls. Basically, they created a network of telecom operators, meaning mobile phone operators, and the regulatory authority, telecom regulator, TRAI is what they call. And basically, they register whoever wants to send messages, right? They have to be registered in this network, which is on blockchain. And that way, only those folks who are on that registered folks on the network can actually send the messages. So they're using this system to eliminate spam messages. So that's another use case, and that's a large scale. Millions of people are using that system, and the reason I wanted to cover these examples, you can see blockchain is not just theoretical or hype anymore. There's still hype in a lot of the startup. We talked about the cryptocurrencies and like metaverse, gaming, and all that. So there's a lot of hype and there's a lot of excitement, experiments going on in that field. But as far as like enterprises and governments, they're really working on real use cases, and some of them are already live. So that's the last slide on the technical part. And you can reach me through LinkedIn. You can email me. Also, I would like you to take a look at the website blockchain.ieee.org. I serve as a co-chair of this initiative. And I'm also leading, as I said, the IEEE Puerto Rico and Caribbean blockchain group. And we are actually planning a couple of hackathons this year, one in like the last week of May. And we are actually inviting students from all engineering universities, just not limited to the list here. Just these are just 5 that I put up here, but we are open to any engineering university or students. We welcome all to actually participate in this hackathon, and we have some prize money. And we're also looking for volunteers from each one of these universities. So please do reach out to me um, at this email address. You can also ping me on LinkedIn. And in December, second week, like last year, December 2021, between like December 5 and 10, there was a Puerto Rico blockchain week. There was a whole week of blockchain events, like pretty much Monday through, I think, even Saturday. So this year, there's going to be a similar, or I guess, second blockchain Puerto Rico blockchain week, around second week of December. So we are actually, we meaning IEEE, we are planning a blockchain event, and we plan to have like a one day technical research talks. We plan to invite all university researchers to come in, or students as well, graduate students to come and present their research work. And then day two, we would have a hackathon similar to the one in May. So if you're interested, please reach out to me. And I think I'll stop here and see if there are any questions. Okay. I guess we'll stop here. Please do stay connected. Again, go back to my LinkedIn page. Yeah, you could ping me on LinkedIn, and also check out the blockchain.ieee.org. Thank you.